So good morning, we're starting with 4.2 patterns and functions, and we're going to identify functions, find the domain and range of the relationship and the functions. So a function is a special type of relation that pairs each domain value with exactly one range value. A function is a set of ordered pairs in which x element has only one y element associated with it. What that is saying, guys, is that you cannot repeat the x value, okay? So for every one x, there's only one y. So for every x, there is one y. And the x cannot be repeated. This will be easier to spot when we see the charts and we see stuff with actual numbers. So the domain of a relation is the set of first coordinate or x values of the ordered pair, and the range of the relationship is the set of the second coordinate or the y values of the ordered pair. Usually in an ordered pair, you guys have x comma y. Not usually, that's how you write them all the time. The domain is the x, and the y is the range. That is always going to be the case. That is never going to change, okay? So if you have a bunch of values, let's say 1, 0, 3, 5, 4, 2. Here, the 1, 3, and 4 are all domains. And here, the 0, 5, and 2 are all range. I color coordinated it with red and blue for this example, but that's always going to be the case. The x is always a domain, and the y is always the range. So they give the domain and range of the relation and then tell whether the relation is a function and explain. So again, the domain will be all of the x's, so I'm going to write them down. 3, 5, 4. Usually you don't repeat, but we have a 3. We don't have to write it out again because it's repeated, but I'm going to write it in right now and highlight it just so we mark the fact that this is repeated. And then the range are all the y's, so -2, -1, 0, and 1. Usually you write it, guys, from least to greatest. Right now it was in that order from left to right, but usually you write it from least to greatest. Now, is this relationship a function? No, it is not a function. The reason that this is not a function is because the 3's that we highlighted right here repeated. So x repeated a value. So now that given the domain and range of the relationship, tell whether the relation is a function and explain why or why not. Now guys, when they give it to you in this form, the x is always going to be the left one and the y is always going to be the right one. Now, remember, in a function, the x cannot, so x cannot be repeated. This is the keyword not. But in a function, the y can be repeated. For the people that may not know, these lines mean the same thing as the top. So when writing those lines, it's just the word function. Now, let's figure out if this is a function or not. Let's look at the x's. Right? Does any of the x repeat?
No.
Is there more than one value of the x for every y? No, right? What I mean by that, if you saw the other example, you had like 3, 4 and 3, -2. That means you had 2 x's or the same x for 2 values of y. In this case, that's not happening, so I'm going to erase that.
What are the red?
So since they're not repeated, this is a function, so yes, the x does not repeat. Now, there was a question about the red arrows. Now, all that means is that's the order pair. So if you go to 4 to 2, you get your order pair of -4, 2. -8 to -2, you get an order pair of -8 to 2. From 4 to 1, we get 4, 1. And then the last red arrow is 5, 1. So we gotta determine whether each relation is a function and explain. So let's look at A. We got -2, -1, 0, 1, and 2. We got no repeated x's. So yes, this is a function. X does not repeat. Now for B, again, let's look for repeated numbers. We got 4, 8, 6, 4, and then 5. 4 and 4 repeated. So no, the x repeats. For C, we got -2, -1, 0, 0, 1, and 2. Here they're right next to each other, the 0 and the 0. So no, the x repeats. And then for D, we have, I'm going to write the order pairs, -1, 4, 3, 15, and 11, 15. Again, no x repeats, so yes, x does not repeat. Just so you guys know how it looks, if it were to repeat, for example, this would be a backwards arrow. It would be like this, okay? Or you would have an order pair. Let's say we have -1, 3, 11, 0, 4, and 15. This is just an example. And 16, we have, let's say, this, like that. You guys see how 2 arrows come from 3? That will be another way so you guys could be able to tell that it's not a function because there's more than 1 arrow in the x. So it says to determine whether each relation is a function and explain. So again, we have to look at the x right now, -2, -1, 0, 1, 2. None of the x's repeat, so yes, this is a function. The x does not repeat. And then we have B, so 4, 8, 6, 4, 5. The 4 repeats, so no, x repeats. This will be a lot easier to spot, guys, when we're doing it in a graph. As of right now, we're not using a graph. We might later. We will later, not might, we will later in this lesson. And it will be actually a lot easier to spot. Okay? So you'll be able to look at it and you'll be able to just say, hey, yeah, that's a function, or hey, no, that's not a function. All right, so let's start. They're asking us to determine whether each relation is a function and explain. So we have -2, -1, 0, 0, 1, and 2. Again, they repeat, so no. X repeats. And then it tells you on the side before example D, remember a relation can be represented by a mapping diagram. A mapping diagram is what you guys see. A bubble and then arrows pointing, okay? It could even be like this. That's what it is, just the name of the diagram. Now we have 1 and -4, 3 and 15, and 11 and 15. The x's don't repeat, so we're good to go. This is yes, x does not repeat. It says determine whether each graph represents a function and explain why, or just explain. Now, this is what I was telling you about the graph. It's a lot easier to spot. There is a test guide called the vertical line test. What that is that you can draw, let me write down what it is. You can draw a vertical line anywhere on the graph and you will only touch the graph in one place. Well, let me write it because it's the line, not you. And it will only touch the graph in one place. Place or point. Now, what does that mean? You guys see how A has this red line on top of these 2 points like this? That's a vertical line. You see how it's touching a point right here and right here? Because it's touching 2 points, that is not a function. Okay? If I could actually draw another line right here, and it's still not a function because it's touching 2 points. Now, it's literally anywhere on the graph. So it could be, you can have a graph that has point here, point here, point here, point here. And it's only at this one point where the lines collide with the points. It is still not a function, okay? So as long as it touches it in one place more than once, that's it. It's not a function, okay? So in this case, A is not a function. We do the same thing for B. Do you guys see we can draw this vertical line absolutely anywhere on this line, and it still only touches one point of the graph? So because it only touches it in one point of the graph, this is a function. So yes. Does that make sense? The explanation, I'm giving it to you verbally, which is the vertical line test, or the fact that no points repeat on the x-axis, because that's what's happening right here. There's 2 points for 2. Or there's 2 points for 5. But in the other graph, in B, there's no repeated x's, so there are no repeated points, so therefore it is a function. So this slide is determine whether each graph represents a function and explain. So if you look at the first graph, I'm going to number this one A, this one B, and this one C, just to have a point of reference. A is if you draw a vertical line on this circle, it touches more than one point in all of the lines that I drew. So this is not a function. I'm going to put vertical line test as my explanation. Now for B, I can draw a vertical line anywhere on this graph, and it just touches one point. No more, no less. So yes, again, the vertical line test. You could also put that the x doesn't repeat as an option. So as well as for the first one, you could have written down x repeats. For C, we can draw a vertical line. And actually, in some of these places, even more than one line touch. For example, right here, it touches 4 times in that yellow highlighted area. So definitely not a function. Again, you can say vertical line test. Or you can say that the x repeats. Either one is valid. If you're going to say vertical line test, draw at least one line that proves yes or no. Okay, I just drew a few to try to aim for as many lines as you guys could draw. All right, you guys do have homework. It's on Canvas. But that is it for the lesson.